Hi, this is Om Gupta. I'm here to show you what I've built for Hack with Chennai, that is DealDNA. DealDNA is a sales agent that remembers every account and drafts the next follow-up using its own memory. The fun part isn't that it remembers, it's that giving it a memory made it cheaper to run and not more expensive. Let me show you why. Here's a cold account. There are multiple cold accounts that you can see on the left side. The agent barely knows anything about it. So let's say this policy wala insurance. And watch what happens when I ask it for a next action that is to be taken. So we already have an inbound lead for Policywala Insurance. We have a company compliance head, which is Arjun Rao. Now we'll ask the next best action that can be taken. And what we see is with no memory, all it can do is a plain discovery ask. Looking at this routing panel on the right, you can see that it runs on the cheap model, that is the free model, because there was nothing hard to think about here. There was no context that it had previously. There was just an inbound lead that we had. And for now, just hold that thought about how it used the free model. And it gave us a follow up that we can go through with. Now, let's look at BKG Foods, for example. We're at the negotiation stage. There's already been an intro call, there has been a discovery workshop, there has been a budget signal, there's a product demo, and there's also been a competitive pressure call because they had some other competitor who was pitching the same idea to them with a cheaper quotation. So there's a certain bit of complexity here. And what happens here is these five interactions are saved into the account's memory. So every one of these got written into hindsight. Now, when I hit draft, what happens is obviously we get the drafted follow-up that is to be taken place, but you can see it uses recall and it uses hindsight reflect function, which basically pulls back the objections and signals and reflects to work out what is the next move that can be taken. So the memory is actually thinking and doing like the heavy lifting as well. Now, as you can look at the dashboard, it shows the exact things on record. So you have see the model, the provider, the cost, all premium saved, how much percentage you saved. Now we have an audit trail over here, so you can see the total lifetime spent, how much dollars you've saved, and also you can see that the India data residency requirement, the SSO deal breaker, the competitor quote, the CFO asking about the price. It even gives a champion something to forward internally. Now here's the payoff. This one went up to the premium version and it used a premium model. We had seen earlier Policywala used the free model, and this is done on purpose. The cheap model failed because the quality check was not good because there were many conflicting signals. We had a lot of previous memory in place, and that's generally something hard to draft initially without much context. So it used the expensive model on its own and escalated the same. And the cold account, which was the policy while insurance, it didn't seem fit to do so. Now, the tool Cascade Flow runs the cheap model first and only moves up when it has to and when it's required, and also when the budget runs out. So you can see here we have a pipeline budget. We've set it to $1 for now. This is how much progress has been done, and it's not much, right? And we also see that once, let's say, we run this again, for Chai Point, you see that it drops to a local model instead of crashing. And how many ever drafts there are? There's a 50, it's still inside the budget, they're still working. And every decision that is made is logged, and the model cost, savings, and why it was routed the way it should. How many runs have been done. And now you can see there are some stats over here, which is saved versus all premium and on cheap tier. So what surprised me isn't that memory isn't just a quality thing, it's a cost thing as well. You would think that using memory, more tokens are being used to save more information. But once the agent remembers the context, more drafts get easier, so it doesn't require more complex thinking as well. And as it does not require complex thinking, it requires easy thinking, and easy thinking does not need expensive models, right? So the memory made the work actually easier and costing us fewer tokens, and the runtime layer also cashed in at the right time. This whole combination was the idea we had in mind. I had in mind, and yeah, that was it from my side. That was DealDNA. I've put the repo link in the description. Do check it out.